Okay, our topic for today is all about improper integrals. So, improper integrals, definitions, and integrals of x of dx of a from negative b is improper of either the interval of integrations of infinitely long or if the function has singularities in the interval of integrations or both. So there are two types of improper integrals. So type 1, infinite limits of integration. So example, integral of 1 over x squared of dx of 1 over infinite, and the type 2 discontinuous integrants of vertical asymptotes. Example of integral of 1 over x squared of dx of negative 1 from 1. Then the definition 1, integral with limit of integrations are called improper integrals of type 1. So first, if f of x is continuous on a and infinite, then integral of f of x of dx of a from infinite is equal to lim b approach to infinite, and integral of x of dx of a from b. And second, if f of x is continuous on negative infinite and b, then integral of f of x and dx of b from infinite equals to limit of a approach to limit infinite integral of f of x dx of negative a from b. And third, f of x is continuous on infinite of and infinite, then integral of f of x of dx of negative infinite and from infinite is equal to integral of f of x dx of negative infinite from c plus integral of f of x of dx of c from infinite is equal to c is real and any real number. So type 1, this is the formula and also the solution. So infinite limit, so this is the diagram, I think, and also this is the solution. So integral of f of x of dx of negative infinite from b is equal to limit over approach to negative infinite integral of f of x of dx of a from b, and integral of f of x of dx of a from infinite is equal to limit approach b and approach to limit infinite, and integral of f of x dx of a from b, and integral of f of x dx of negative and infinite from infinite is equal to integral of f of x of dx of negative infinite from a plus integral of f of x dx of f of a from infinite. Convergent and divergent first kind. The improper integrals f of x of dx and integral of f of x dx are called convergent of if the corresponding limit exists, and divergent if the limit does not exist. So example 1, determine whether the integral of 1 over x of dx of 1 from infinite is convergent or divergent. So the solutions according to part A of definitions 1, we have integral of 1 over x of dx of 1 from infinite is equal to limit of t approach infinite integral of 1 over x of dx of 1 from t is equal to limit over t approach to infinite integral approach x and from 1 to of 1 to and 1 of t and is equal to limit over t approach infinite and integral of t negative integral of 1 is equal to limit over t approach to infinite integral is equal to infinite. The limit does not exist as an infinite number, and so the improper integrals of 1 over x dx is divergent. So the definition 2, integrals of functions that become infinite at a point within the interval of integrations are called improper integrals type 2. So okay, first, if f of x is continuous on a and b and discontinuous at a, then integral of f of x of dx of a from b is equal to limit over c approach a positive integral of f of x of dx of c from a. And second, if f of x is continuous on a and b and discontinuous at b, then integral of f of x of dx of a from b is equal to limit c approach b negative integral of f of x and dx of a from c. And the third, if of x is continuous of c and a and b is continuous elsewhere, then integral of f of x dx of a from b plus integral of f of x dx of a from b. So in each case, if the limit is infinite, we are that time improper integrals converge, and that the limit is the value of the improper integrals. If the limit fails to exist, the improper integrals diverge. So determine whether the integrals of 1 over x of dx of 1 from infinite is convergent or divergent. So the solution, A, definition 1, we have two integral of 1 over x of dx of 1 from infinite is equal to lim t approach to infinite, and integral of 1 over x of dx of 1 from t is equal to lim over integral t and approach to infinite integral approach to x and of 1 from t and is equal to lim over t approach to infinite and integral is equal to infinite. So the limit does not exist as an infinite number. So the improper integrals 1 over x of dx is divergent. So find the integral of 1 square root of x negative 2 of dx of 2 from 5. So the solution, we note first that the given integral is improper because has the vertical asymptotic x is equal to 2. So f of x is equal to 1 over square root of x negative 2. So since the infinite discontinuity occurs at the left endpoint, so integral of dx over square root of x negative 2 of 2 from 5 is equal to limit of t approach to 2 positive integral of dx over square root of x negative 2. So, 2 and 5, we are use part B of definition 3. So, the proper integral of third kind, it is a definition integral in which one or both limits of integrations are infinite and the integrand becomes infinite at one or more points within or at the end points of the interval of integrations. Thus, it is combination of first and second kind. So, that's L. And let's continue. If it is continuous on negative infinite and f integral of f of x dx of negative infinite from a and integral of f of x dx of a from infinite both converge, we say that integral of f of x dx of negative infinite from infinite is equal to integral of f of x of dx of negative infinite from a plus integral of f of x of dx of a from infinite. So, if either or both in the integrals on RHS of this equation, divert diverse the integrals of an f of form. Thank you. Thanks for watching.